Hello, welcome back. In this lesson, we're going to talk about abstraction. In our list is the second principle of object-oriented programming. Previously, we have discussed about encapsulation. Encapsulation is a principle where you combine data and code into a single class. For example, employee class holds the activity like adding an employee. At the same time, the data, employee name, social security, salary, combined together into a single class. Whereas abstraction is a principle by which only essential details are exposed to the user. In the same example of an employee, I can expose add name, add salary, add SSN. But I don't want to expose certain methods which calculates bonus and commission for the employee, which is combined together into single component salary. That's what I want to expose to the user, but not the intricate details how the commission is calculated and how the bonus structure based upon the rank of the employee. Those details I don't want to expose to the user. So we will see an example where encapsulation in action. So if you look at here, encapsulation is data hiding, that is information hiding, while abstraction is detail hiding. So detail hiding means hiding the method details, whatever it is, how the method is written, or exposing the method itself to the caller. In Java, we can achieve abstraction by using either abstract classes or interfaces. Interfaces are 100% abstraction. So we will see the differences between an abstract class and an interface, which is a very popular interview question in a separate lesson. But for now, keep in mind, abstraction is achieved by using interfaces or abstract classes. We will see an example now. So let us start with creating a class which has an abstract method in it. So in this example, we'll create a class animal, and the animal class will have a method which is an abstract and non-abstract methods. When I say abstract method, it does not have any implementation for that method, and the method itself declared as abstract. Let's take a look at it. So here I'm creating a new class, and the class name is animal, and that class will have an abstract method. To make it more sense, let us add some methods which are relevant for any animal. Let us say it can be move, eat, sleep, make sound. Okay, these are the various methods. So let us start with move and eat. I will create two methods with that behavior. Since moving and eating is a common behavior for any animal, in most cases, not going too logically. So, and make sound is different for each animal. Each animal makes a different kind of sound. So that is the method I want to make it abstract. I will explain in a little bit why I have chosen that method to be abstract. So if a class has an abstract method, the class also should be an abstract, because there is no implementation for an abstract method within a class. So this should be an abstract class. So let us dive in a little bit. What does literally this abstract keyword means here? So what it means is, make sound is a method that will not be implemented within this class, whichever class that is going to extend class animal will be implementing make sound method. So if you notice here, the method, how it was declared is it doesn't have a curly braces like other methods which are non-abstract. Okay, so this might be confusing in the early stages, but it is pretty simple because abstract is nothing but no implementation. Abstract, it's very vague, right? So abstract means no implementation, no clear picture at the time. So the reason I have chosen as a designer of this program, because the sound is different for each animal, whether it's a dog which barks and cat meows and donkey, whatever sound it makes. So the sound is different for each animal. I want to keep that abstract and leave the implementation, how it works, to that animal, the specific animal itself. So I have decided to declare make sound as an abstract method. It makes more sense once we start using this animal class in creating dog, cat, or donkey classes. We will see that in a little bit. So, and the two methods above, move and eat, those are implemented in this class itself. So if I put like sysout, you can do your detailed implementation, but I can do a sysout in this method and a sysout on this method. And abstract is a method that is not implemented here, so we don't have the curly braces. That's the syntax for the abstract methods. Now let us create a new class, which is a dog class, and finish. This is where one more new keyword I'm introducing it to you. We are jumping ahead of time. Extends is a keyword related to one more principle in object-oriented programming, which is inheritance. So we're going to see a little bit of inheritance while we are talking abstraction. So in Java, you can extend a different class into a subclass. So when I do dog extends animal, and that carries the methods that are already there in animal class. So move, eat methods are readily available now in dog because we are extending it, we are inheriting it. Just like child inherits certain properties, certain features of their parent, this is exactly the same. Dog is inheriting certain things from animal. For example, move and eat are inherited into dog, but not make sound, because make sound does not have an implementation in animal. So we are forced to implement make sound method in dog class. So let us see what is the complaint here. So when I mouse over, it says I need to add unimplemented methods. Let's click on that, and if you notice here, it is forcing us to implement make sound in dog class. So here you can implement the dog sound, sysout and print out woof woof as the dog sound. So here we have implemented an abstract method from parent animal in subclass dog. Similarly, if I create cat, I will implement that method in cat. Specific sound I will include in that cat class. Hope you're getting it. So the abstract by principle, it is hiding the implementation and let the subclasses implement the method for them. So it's a design principle basically. So in what situations you do that, it based upon, generally the parent classes will be abstract and forcing the subclasses to implement that. In the similar way, if you are defining a vehicle, right? And vehicle can have different kinds of subclasses: cars, trains, aeroplanes, trucks, and everything. But you want to force your developers to implement certain basic methods in each and every subclass, like move forward, move backward. As such common methods, you will write them as abstract in the parent class and force the implementers to implement them in their subclasses. Like I mentioned earlier, abstraction is achieved by interfaces and abstract classes. In this example, we have used an abstract class and an abstract method within the abstract class to demonstrate abstraction. So we will leave the interface to a different session, and let us conclude this lesson going back to see the definition one more time so that to consolidate everything. So here in encapsulation is, let us reiterate, because these are a little bit close to each other, encapsulation and abstraction. These two are two comparable principles, not similar, but we want to compare them to understand, because they deal with hiding certain information. In encapsulation, it is information hiding. We're creating an employee object and we're declaring member variables salary, name, and social security number as private member variables, and we are only exposing methods set name, set salary, set SSN, right? We are not exposing the real member variables. Those are private. Whereas the methods, we want to expose them to the user. So any kind of changes to the name, salary, or department, whatever, it should come through the methods, not through the member variables, because these are no longer accessible if you declare them as private for the caller. So that piece is basically information hiding, while as abstraction is dealing with implementation hiding. So we want to hide the implementation in the abstraction. So here we completely avoided the implementation by declaring it as abstract method. So the implementation will take place in the subclass where it extends the abstract class and implements in the subclass. The main advantage of using abstraction is you are leaving the implementation details to the respective class rather than implementing certain functionality in the parent class and again overriding them in the subclass, irrespective of whatever the implementation would be. So you don't want to repeat the code in the parent class and the child class. In that case, you can simply declare the method as an abstract and leave the implementation details to the subclass. There might be certain methods you want to implement them in the parent class and certain methods you don't want to implement them in the parent class. Those methods which you don't want to implement, that can be declared as abstract, and abstract will force the subclass to implement it. So if I don't implement this class, if I delete this class and do Control S, if I mouse over that, this won't compile. It will complain either I have to make the dog class an abstract again or implement the unimplemented methods. So the first one, if I click on that, it will auto generate this piece of method for us, forcing us to implement that method. So the abstraction is a great concept for code maintainability and also delegating the implementation to the subclasses rather than writing in the parent class itself. With this, I will conclude this lesson. At a later point of time, we will discuss about interfaces, which is also a great way to achieve abstraction. Now you may move on to the next lesson. Thank you.